Welcome to the part 3, Mining and Consensus from the Introduction to Blockchain series. We will be focusing on mining process and the role of consensus mechanism in blockchain. Let's start by understanding what is mining and who is the miner. Mining is the process of adding transactions or blocks to the blockchain. It involves creating a hash of block of transactions that cannot be easily forged. This helps in maintaining the integrity of the blockchain without the need of a central system. Hence, it enables the decentralized nature of a blockchain. Miners are the nodes involved in mining. The mining process requires fast CPU, high electricity usage, generates more heat than typical computer operations. We can deduce that mining process is expensive. So what is the incentive to do it? Simply the Bitcoin reward. Two terms are in use in mining: nonce and difficulty. We heard about the nonce in the previous part, which is a field of data found in every block. This nonce field is what mining is all about, where the difficulty is a value decided by the blockchain network itself. It should be clear that there is no formula for calculating the nonce. Miners change the nonce again and again until hash falls below the difficulty, which is the target. Here we are at the most important part of the blockchain, the consensus mechanism. After all the previously mentioned concepts about blockchain, someone may ask how the distributed network agrees to add blocks to the network or chain, how to decide, in case of a fork, which chain to grow. If two blocks are entered into the blockchain at the same time, how to decide which block to add first? The answer's consensus mechanism. It guarantees integrity and consistency, ensures a common unambiguous ordering of transactions and blocks, and protects against attackers. Moreover, consensus protocols maintain the sanctity of data recorded on the blockchain. Also, it provides the building blocks that allow the blockchain platform to function correctly in normal as well as adversarial conditions. Different techniques are used by different blockchain platforms. As an example, Bitcoin solved this problem by using proof-of-work, where the nodes are obliged to prove that they have expended certain amount of energy, while the Ethereum metropolis uses ProofofStake. One of the most used consensus algorithms is the proof-of-work. It's a piece of data with three characteristics: difficult to get in terms of cost and time, easy for others to verify, satisfies certain predefined conditions. Taking a look inside the block header, we will find four components with one variable only, which is the nonce. Assuming this part as the entire hash space, with a small target here representing the difficulty scope. To achieve the proof of work, the miners start incrementing the nonce variable with every iteration until hitting the target, which means falls inside it. At that moment, the first miner satisfying this condition sends to the network his proof of work for validation and getting the reward once it's approved. We should understand that the data in a candidate block is invariant. Hence, a hash of an invariant is also invariant. The miners thought about the easiest way to vary an invariable by appending an integer to be incremented with every iteration until hitting the goal. This variable is the nonce. The below example, we assume that the data block is represented by hello world, then we have a target to get a hash starting with at least three zeros, and here we are. We started with a 0 as a value of a nonce, incrementing until getting a hash that starts with at least 3 zeros, which is achieved with the value of 4 to 50. This value is called the golden nonce. The miner who first solves the proof of work by finding the target publishes the results to the entire network. All the other nodes can easily verify the result and consequently agree on the block validity and the new state of the blockchain. The successful miner is rewarded and new bitcoins are generated in the system. Proof of work allows anyone with a processing unit to participate in the process of creating new blocks. It validates the legitimacy of the transaction. It allows the network to reach consensus and avoids issues such as double spending and cyber attacks. It introduces new cryptocurrency into the system at a steady rate and rewards miners. Also, it makes blocks tamper resistant, as we mentioned earlier. What is the drawbacks of proof of work? The high amount of power consumption, and the nodes with powerful processing units will dominate. This means will control the blockchain. To overcome the drawbacks of proof of work, proof of stake was found. In contrast to proof of work, in proof of stake, the creator of the next new block is chosen in a deterministic way, based on its wealth, which is defined as a stake or an escrow. The stake, which is cryptocurrency, refers to the possession of tokens in the system. What is the benefits? Number one, less power consumption. Also, the increased protection from malicious behavior in the network. Since attacks are highly expensive, where the attackers need more than the half of the stake to be able to maintain the longest chain and manipulate the blockchain. Malicious transactions are also reduced, where the network rejects the transaction and forfeits the escrowed stake. What are the drawbacks? Obviously, the nodes can predict which node will have the right to create or forge the next block with a reasonable probability based on its stake. This means the older and larger set of stake can control the chain. Below, we summarize the main differences between proof of work and proof of stake. Where miners use their computational power in proof of work, validators depend on their stakes. In terms of attacks, hackers at least need 51% of computational power to control the network in proof of work, which is impossible in proof of stake. We reached the end of part 3. Thank you for your attention. If you're interested in smart contract and digital trust, kindly watch part 4.